Recording. Okay, this is being recorded. So if you want to go back and look at this lesson, you can, because there might be times where you want to look at another example more in depth, or you may want to just watch it again. Trig can be a very difficult topic to understand, but once you understand it, the nice thing is you solve all problems the same way. All right, so let's go ahead and begin in prayer. Son, Holy Spirit. Glory be to the Father, to the Son, to the Holy Spirit.
As it was in the beginning, is now,
As it was in the beginning, is now, never shall be, world without end. Amen. All right, sorry about that. All right. The main objective for today is to be able to solve right triangles using trigonometry. Okay, what do we mean by trig? Using sine, cosine, and tangent. Before we do that, on page 103 in your workbook, it's not homework. What I want you to do is to review page 103 in the workbook before you try to do the homework problems. This will make sure you understand the language that's being used, and it should make the homework problems a lot easier. What I've done is I've already posted the solution to problems 1 through 11 in class announcements in Blackboard, and I think you can download them. Even though you can't turn in homework yet, you can still go to class announcements and get this document, okay? And that document also contains your homework, okay? It has some homework problems that I want you to solve, just like we're gonna do at the board over here. And I even did 3 of them for you on this handout, so you can just follow my example right there on the homework. So 3 of the homework problems are your examples. I did them for you. Use that as an example. I want you to show your work. It's real important to show your work because all tests and quizzes are going to be take home. So really you're going to get graded on your work, not your answer.
Is that on Blackboard, the link?
The link is on class announcements in Blackboard. That's correct. Okay. And the link will give you both of these. It'll give you this handout for homework and the page 103 solution. You don't have to turn the page 103 solution in. I just want you to look at this first because it should help make the homework a lot easier. And the homework's not due until next class. Okay, so next class for us is Thursday. So just try to put it into Black Box before Thursday at 10 o'clock. Hopefully Blackboard's back up here real soon. If not, we may have to go by an email system for a few days until we get Blackboard back up and running, but hopefully Blackboard will be up soon. Your daily quiz, I was not able to get those graded before Blackboard went down, so I don't have access to them yet. It is going to be optional for everyone. Okay, so once I do get those grades in there, if you don't like the grade or don't want the grade, just shoot me an email and let me know and I'll take it out. Okay, so that first daily quiz is optional. The grade is optional. If I grade it and you like it, let it stay. If you don't like it, let me know, I'll take it out. And I do have office hours, all right, Monday through Friday. Monday through Thursday, I'm always available at this link, 2 to 2:30, and on Fridays, 9 to 9:50. All right, so if you ever have any questions, just hop on that link and I'll be able to address your issues for you. All right. So I have my computer on a cart, so we're just going to roll through class today. Before we get started with class, I want to go back and look at a couple homework problems. All right. The first homework problem I want to look at was the one from last Friday. That was not the page 101. That was the handout that you turned in. Problem number 13 on that had a problem that looked like this. It had 3 30, 60, 90 triangles. This black one, okay, because if this is 60 and this is 90, I know this angle's 30. So that black triangle is a 30, 60, 90 triangle. This white one over here, this is 90 degrees, this is 30, so this has to be 60. So this is also a 30, 60, 90 degree triangle. Okay? And if you look at the big triangle is also a 30, 60, 90 degree triangle. So I have 3 30, 60, 90 triangles all smashed up into one diagram. That's what makes this problem confusing. Okay, what do we know about a 30, 60, 90 degree triangle? Now, I know that anytime I have a 30, 60, 90-degree triangle, if I know the short leg, the hypotenuse is always what? If I know the short leg is 1, I know the hypotenuse is double that, so it would be 2. And I know the long leg is always this one times the square root of 3. That was last week's class, okay? And last week's classes are all posted on my new YouTube channel if you need to go back and review that. This is always true. Okay? So this black triangle right here, is this the short side, the hypotenuse, or the long leg? Which one is that for the black triangle?
Short
Short
side.
side.
It's the short side. So I know this side here would have to be what? 8. And this side, CD, would have to be what? 4 times the square root of 3. So CD is 4 times the square root of 3 because the long leg is always the square root of 3 times bigger than the short leg. So would everybody agree with that? Now notice I haven't gotten AD yet. My goal is to be able to find AD, but I couldn't go right to finding that. I had to find this first. Because now that I know this, CD is 4 radical 3, look at the white triangle. That's another 30, 60, 90-degree triangle, isn't it? Is this the hypotenuse, the long or the short leg?
Long.
It's the
Long
short
way. Oh,
leg. Well, let's take a look. Is it the side across from the 30-degree angle? If it's across from the smallest angle, doesn't it have to be the shortest side?
yes.
So that's the short side. So this is the long leg. Well, if I know the short side, what do I do to get the long leg? I multiply by the square root of 3. So all I have to do is take 4 times the square root of 3 and multiply it by the square root of 3 to get AD. Good review of radicals. What is the square root of 3 times the square root of 3? What would the square root of 3? 3. Square root of 3 times the square root of 3 is 3, times 4 is 12. So the answer to that question was 12. Okay, that was one on the homework that I think was confusing, but mainly what made it confusing is the fact that it was just a bunch of 30, 60, 90 triangles all smushed up into one figure. All right. For the daily quiz, here are the answers to the daily quiz. So if you wanted to write these down, 1 was acute, 2 was 2 radical 21 or 9.17. Number 3, there was no answer to. And number 4, X was 6 and Y was 3 radical 3. For number 3, that was a difficult question, mainly because I forgot to put the word isosceles into that question. So technically for number 3, there was no answer, okay? But since that was not my intent, I gave everybody credit for problem number 3 on the daily quiz. Because all you knew about problem number 3 is that it was a right triangle and the hypotenuse was 16. That was all you knew. Well, if the hypotenuse is 16, it could look like the black line, or it could look like the green line. Okay, so you don't know what these angles are. So I couldn't say that it was 30, 60, 90 or 45, 45, 90. Okay, so you don't have enough information to solve that problem. What I intended for it to say was that the triangle was isosceles. If it was isosceles, that means these 2 legs would have to be the same. And what do we know about that means this would be 45, 90, and 45. What do we know about a 45, 45, 90? Any leg times the square root of 2 gives you the hypotenuse. Any hypotenuse divided by the square root of 2 gives you a leg. So that's 16 over the square root of 2, and this is 16 over the square root of 2. They're both the same. However, we can't simplify it. We can't call it simplified if we have a radical in the denominator. Who remembers how we get rid of the radical in the denominator? Anybody? If we have a radical in the denominator, we can take that radical and multiply it by the square root of 2 over 2, because now the bottom becomes what? Square root of 2 times the square root of 2 is the square root of 4, which is just the number 2. And this is 16 times the square root of 2. 16 over 2 simplifies to 8 radical 2. Okay, that was the intended answer for this problem, but I forgot to tell you that it was isosceles. If it was isosceles, you should have been able to realize that the hypotenuse is 16. If you divide it by the square root of 2, you get the legs. Because what we know in a 45, 45, 90 is if you know the leg, all you have to do is multiply it by the square root of 2 to get the hypotenuse. So here we're just going backwards. Okay? But everybody got credit for that problem. But I do want to make sure you understand how to do the intended solution. All right? All right. So we're going to roll into today's class. Before we start, let's just talk about some of the tools that we have for our use right now, okay? Right now, I have some tools in my toolbox for right triangles, okay? All of these tools right here apply to right triangles. What is a right triangle? A triangle with a 90-degree angle in it. It has to have a 90-degree angle in it. If it's a right triangle, can I apply my Pythagorean theorem? Yes.
Yes.
I know two sides. I can go a squared plus b squared is c squared, plug in my two known sides, and find my third side. So that's one tool that I have in my toolbox for right triangles. From last week's classes, we also noticed the 45, 45, 90. Just like we talked about over there, if you know it's a 45, 45, 90, if you have one side, you can find the other two sides, right? If it's a 30, 60, 90 triangle, just like the other example we did over there, I know all the angles. If I know one side, I can find the other two sides. And notice, if I know all three angles and I know all three sides, I have solved the triangle. What does it mean to solve a triangle? Find all the angles and all the sides, the three angles and the three sides. So here's all the tools we've talked about up till now. A special case where it's 30, 60, 90, a special case where it's 45, 45, 90, and the Pythagorean theorem. What we're going to learn is the trig tool today. The trig tool works on any triangle that is a right triangle. It has to have the 90, but it can be 20, 70, 90. It can be 10, 80, 90. It's a very powerful tool. In fact, the trig tool will do everything up here. If all you know is this trig tool, you can solve all these questions, all the triangles, okay? The one we're going to look at today is if we know one side and one angle, how do we get all the other sides and angles? Okay? Next class, we're going to look at if we know two sides of a right triangle, how do we get all the other sides and angles? So the trig tool is very powerful. It's like vice grips. Vice grips can be used as pliers, as a wrench, or as a vise. The trig tool will solve problems that all these tools will solve. This will do all of them, okay? And it's really three tools in one. It's the sine, cosine, and tangent tool, okay? And we're going to learn about all three of those today, right? So if you want to go back and replay this video and put this in your notes, this is a good guide to make sure you know what tool you're getting out of the toolbox and how to use it. And remember, all the tests and quizzes are going to be open note. So if you want to have this written down instead of using your theorem sheet, feel free to do so, okay? So now let's take a look at an example problem. Okay, we're going to do a problem that we already know a lot about. I know this is 30. Let's say I didn't know that. Let's say all I know is BC is 10, it is a right triangle, and I know this side is 30. I mean, this angle's 30. So I know one angle and I know one side. But if this angle's 30 and this angle's 90, I really know this angle up here, don't I? What's that angle have to be?
60.
60, okay? So this is a 30, 60, 90 triangle. I know how to solve a 30, 60, 90 triangle. This is what my notes tell me. That if you know the short side, you double it to get the hypotenuse, you multiply it by the square root of 3 to get the long leg. So if this is the short leg, is 10, what's my hypotenuse? 20, right? What would the long leg be?
10 times the square root of 2.
10 times the square root of 3.
3.
10 times the square root of 3. Because this triangle is basically 10 times bigger than my sample. Take everything here, multiply it by 10, and you get this one, right? So this is a scale version of this one, a bigger scale version of this one. So this problem was easy. I have now solved this triangle. Solving the triangle means you find all 3 angles and you find all 3 sides. Okay. The only reason I was able to do it, though, is because it was one of these special cases that I already know the ratio of the sides. If this was 35, 90, and 55, I wouldn't know how to do it because I don't have a guide for that. But we do now. It's called trig. All right, so let's take a look at trig. We're going to use this problem and solve it using trig. Trigonometry is sine, cosine, and tangent. What are sine, cosine, and tangent? They are ratios. They're ratios of sides of a triangle. If you're talking about the sine function, you're talking about the opposite side divided by the hypotenuse. If you're talking about cosine, the adjacent side divided by the hypotenuse. And if you're talking about tangent, it's the opposite side over the adjacent side. But we need to figure out, I know what the hypotenuse is. Okay, in any right triangle, the hypotenuse is always what side? We know which one that is. It's always what?
The long side. The short side.
The longest side.
Right, it's the longest side, and it's always the side across from the 90-degree angle. So the H in sine and cosine, we know. We know what the hypotenuse is in a right triangle. I don't know what the opposite and adjacent side are until I know where my reference point on this triangle is. All right, so in other words, I like to think of it as I have to know where I'm standing, okay? So if you see sine of 30 equals a ratio, okay, the ratio that it's equal to is what? The opposite over the hypotenuse. It is my opposite side over the hypotenuse. Sine tells me what type ratio I'm using. That's a ratio, that's a ratio, that's a ratio. So if this said tangent, I would put opposite over adjacent here. Because whatever word is here tells you what the ratio is. Does everybody understand that?
Yes, sir.
Okay, to fully understand what the opposite and the adjacent means in the problem, you have to know this guy, where you are standing. In other words, what angle are you standing at? In this example, I decided to stand at the 30-degree angle. So imagine you just come over here and you're right here. You're going to stand right there. You're standing there. This is where you're standing, and this is the type ratio I want. The type ratio I want is opposite over hypotenuse. Well, I already said the hypotenuse never changes, does it? So what is the hypotenuse in this problem? The hypotenuse is 20. So I know my hypotenuse is 20, right? But what I have to figure out now is the opposite. This is the hard part. What does opposite and adjacent mean? Well, imagine you are physically standing here. The hypotenuse is always the hypotenuse. I need to look at these two sides here. If I'm standing here, is this side the one that's across from me, or is it next to me?
Across.
It's across. Okay? If it's across from you, we say that it is the opposite side. If you are standing here, this side is next to you, isn't it? Next to you mathematically means adjacent. So if you're standing here, this is the opposite side, and this is the adjacent side, because my reference point now has been defined. What defined where my reference point is? This number. This tells you what ratio you want. This tells you where you stand to get that ratio. Does that make sense? So now, what is my opposite side?
And
It's 10. So now I know what the opposite side is, 10. See, I don't have to find anything in this triangle. I know everything about this triangle. So the sine, which is opposite over hypotenuse of 30 degrees, which is where I'm standing, is opposite over hypotenuse, 10 over 20. 10 over 20. What's 10 over 20 reduced to?
1/2.
1/2. Okay? The nice thing is, in all 30, 60, 90 triangles, is this ratio always going to be 1/2?
Yes.
Yes.
It's always going to be 1/2. And what's even nicer is you don't have to figure it out. This is in your calculator. Okay? And we're going to do that right now. I want to make sure everybody knows how to use their calculator to get that. The first thing you have to do is you have to make sure that your calculator is in the degree mode, not the radian or gradient mode. It's kind of like putting your calculator into the feet, miles, or inches. Okay, we want to use degrees because that's what this is. This is degrees. So on your calculator, you should have a button that says mode, M-O-D-E. Okay, if you push that button, you should come up with a screen that gives you the option of either highlighting degree or radian. Make sure you toggle down and highlight the degree, not the radian mode. And then you just hit enter, and that'll register your calculator to be in the degree mode, not the radian mode. You will not get the correct answer if you're in the radian mode, okay? You can still get a lot of partial credit for setting a problem up correctly, but you won't get the correct final answer. So if you're in the degree mode, now what I want you to do is I want you to push the sign button, 30, enter. Sign 30, enter. And you should get 1/2. So raise your hand. Let me change my view. All right, now I can see everybody. Did everybody get 1/2? Jack, you got 1/2? Eric, you good? Okay, good. All right, great. Let's just do a couple of, let's do a couple more to make sure we understand how to do that. What if I told you to find the tangent of 30? Okay, what would the tangent of 30 be? On your calculator, what's it tell you?
0.57.
Point what?
577.
Okay, generally we'll write it to the nearest thousandth and then round off to the nearest hundredth. Okay, let's try another one. Let's try sine of 48. Okay, what do you get the sine of 48 to be?
0.74.
0.743, I think it comes out to be. All right, notice it looks like I get numbers less than 1, don't I? Let's think about that. Sine. Sine is what? Opposite over hypotenuse. What is always the longest side in a triangle?
Hypotenuse.
The hypotenuse. So this number on the bottom is always going to be bigger than the number on the top. Well, if you take a number and divide it by a bigger number, aren't you always going to get a number less than 1? So that makes sense, doesn't it? Since hypotenuse is always the longest side in any triangle, sine and cosine are always going to be between 0 and 1. They're always going to be a fraction. Okay? Tangent is opposite over adjacent. That one can be larger than 1 because sometimes this side is longer than this side. And if this is the opposite, then this is going to be a positive, a number greater than 1. Okay? But sine and cosine always have to be between 0 and 1. Okay, so keep that in mind as you solve problems. Let's go ahead and look at, just to make sure, let's look at cosine of, let's look at cosine of 88. Okay, what do you get the cosine of 88 to be?
.034.
Okay, 0.034. It's really small, okay? But it's still between 0 and 1, okay? So finding these on the calculator aren't that hard. So now what we want to do is let's go back to this problem and let's redo it where all I know is this is 30 degrees and this is 10. Only now let's solve it using trig. Okay? I need to figure out several things. I need to figure out which one of these three I want to use, where I want to stand, and then figure out what my ratio is. Okay? I can stand either here or here. I can never stand at the 90-degree angle. Because see, if I'm standing here, I know my angle's 30. And if that's 30 and that's 90, this is 60, and I know what type triangle I have. I can't stand at the 90 because then I don't know if this is 30 and 60 or 20 and 70 or 10 and 80. I don't know what type triangle I have. I have to know what type triangle I'm dealing with to use sine, cosine, and tangent. So there's only two choices I have as to where I can stand in this problem, A or B. You can never stand here, okay? So where do you want to stand, A or B?
B.
B, okay. I want to stand at B, okay? This is where I'm physically going to stand. So I'm going to have 60 degrees in here, right? Because I'm standing at the 60 and it's going to equal some ratio. What I need to decide now is what goes here, sine, cosine, or tangent. Well, I'm physically standing here, okay? I want to find this length and I know this length. Okay, if I'm standing here, what do we call this side?
The hip.
Hypotenuse. If I'm standing here, is the 10 adjacent to me or opposite?
Adjacent.
It's my adjacent. So if I'm standing here, this is the adjacent and this is the opposite. All right. So I don't know the hypotenuse and I'm not trying to find it. I'm interested in this guy because I'm trying to find this one and I know this one. So what trig function talks about adjacent and opposite?
Tangent.
Tangent. That's why I want to use the tangent function. Okay? I want to use tangent because if I'm standing here, I know this, I'm trying to find this. So adjacent and opposite is what I'm interested in. Where do I see that appear? Right here. So I want to use the tangent. And what is the tangent? It's the ratio of opposite over adjacent. It is the ratio of opposite over the adjacent. Okay. Well, I'm standing here. What is my opposite side?
X.
X. Okay, good. I'm standing here. What is my adjacent side?
10.
10. So now I can take advantage of the fact that tangent of 60 is a ratio. It's in my calculator. And it's also X over 10. So I can use it to solve for X now. Go ahead and put the tangent of 60 in your calculator. What do you get?
1.73.
You get what?
1.73.
Tell me you're
One.
coming in.
1.73.
Okay, 1.73 is equal to X over 10. How am I going to solve that? Well, this is a ratio. Is this a ratio? It really is a ratio, isn't it? Can't I just put it over 1? Right? How would I solve this? How do we
Cross multiply.
multiply? What's 1 times X?
1x.
Okay.
Or just
What's 1.73 times 10?
17.3.
17.3. There's my answer. So I now found X by using trig. Okay. Now, let's go back. When we did this initially, we said, well, because it's a 30, 60, 90, and this is 10, I knew this side real quick was just what? 10 square root of 3, right? Which answer is right? This one or this one?
which one?
Well, remember when we did this as a 30, 60, 90? We said if this is 10, this is just 10 square root of 3 because it's the long leg. Why did I get 17.3 using trig and 10 square root of 3 using the 30, 60, 90 model? Is there a problem there?
I don't know.
No, not really, because in your calculator, do 10 times the square root of 3. What do you get? What is 10 times the square root of 3?
17.3.
17.3. It's the same thing. Okay? So it doesn't matter what tool you use. This could have been done very easily because it was a 30, 60, 90. You could have gone right to the answer, 10 square root of 3. But we could have used the trig tool. What's very important is you have to decide where you're going to stand, what it is you're interested in, and what it is you want to find out so you can pick the right trig function. And then once you do that, you can find that ratio in your calculator and then solve for x. Does that make sense? That's the heart of today's lesson, is understanding this example. Everybody think they have that? Because what we want to do now is we want to go solve a problem that's not a 30-degree angle. In other words, we want to do an example where we have no other choice but to do a trig function to solve it. Okay, this one had two ways to solve it because it was one of these special triangles. So if we come over here, can everybody see this example? Give me a thumbs up. Can you see that example? Okay, good. All right. What I know is first thing I have to check for is I have a 90-degree angle. I have a right triangle, okay? So all my tools are in play. I know the hypotenuse. Let's say we want to completely solve this triangle. I want to find these two sides and that angle. That way I'll know all three angles and I'll know all three sides. Can I use the Pythagorean theorem on this?
No.
No, you cannot.
Because I only know one side. For the Pythagorean theorem, if I know two sides, I can find the third side. So I can't use the Pythagorean theorem. Can I use the 45, 45, 90?
No.
This isn't 45. Can I use a 30, 60, 90?
No.
This isn't 30 degrees, it's 37. So I have no other choice in this problem but to use trigonometry to find x and y. Now, z I can find. How can I find z? Z is this angle. How do I find z? What do you think? If I know this is 90 and this is 37.
It's just 53.
It's 53. Because if this is 90, these two angles are complementary. They have to be the other 90 degrees. So I know that 90 minus 37 is 53. Okay? So now I know all three angles. Okay? So I'm happy in solving this triangle for the three angles. Now I need to find the three sides. The only way I can find x and y is to use trig. Okay? So what do you want to find first, x or y?
X.
X. Okay. If I want to find x, I have to figure out where I want to stand. Can I stand here?
No.
Yes. No, you cannot.
You can never stand at the 90-degree angle because that doesn't give you enough information to define the triangle. I can stand here or here because I know these are 37 and 53. And if I know one of these and I know this, I can figure out what my triangle looks like. So do you want to stand at A or B?
B.
B, okay? If I'm going to physically stand at B, I'm going to put my little man here, okay? It looks funny, but that's the way I do these problems because then I never get the ratio. Well, I might still get it wrong, but it helps me out. I am physically standing here. Which one is my hypotenuse?
18.
Which one is adjacent to me?
Y.
Which one is opposite me?
Oh,
X.
X.
Okay, so we said we wanted to find x first. So if I'm standing here, this is my opposite and hypotenuse. What I know and what I'm trying to find. What trig function talks about opposite and hypotenuse?
Sine.
Sine. So I want to take the sine from where I'm standing 53 degrees. Does everybody see that? That's important. You figure out where you're standing, and then you figure out what you know and what you're trying to find. And standing here, this is the opposite and hypotenuse. Opposite and hypotenuse is sine. Does that make sense? Okay. And what is the sine? It is a ratio of something over something. What goes up top? What goes up top?
Opposite.
Opposite. So what do I write here?
X over 18.
The bottom, hypotenuse. What's the hypotenuse?
18.
18. So I know that the sine of 53 is x over 18. Because remember, the sine is a ratio. It's this over this. Okay? Because all my 37, 53, 90 triangles are similar. If I blow this up, this ratio is still going to be the same, isn't it? That's why this can be in your calculator. The sine of the ratio of the opposite to the hypotenuse never changes as long as all I'm doing to this triangle is blowing it up. It's a similar triangle. So the sine of 53 is in my calculator. Okay, go ahead and tell me what the sine of 53 in your calculator is. What is the sine of 53?
7986.
0.7986?
Yeah.
Okay, and that makes sense because we said it always has to be between 0 and 1. So 0.7986 is x over 18. How am I going to solve that? Well, I can make
Multiply it by 18.
Okay, so let's go ahead and do it. What's 18 times 0.7986?
14.375.
14 point what?
375.
375, which is 38, rounded off to the nearest hundred, equals 1 times x is just x. Now I have x, don't I? Okay, so x is 14.38. So this side is 14.38. Now I have some choices to make on finding y. Do I have enough information now to use the Pythagorean theorem?
Yeah.
I do. I could go 14.38 squared plus y squared is 18 squared, and I could solve for y that way. But let's find y using trig. Okay? Do you want to stand? Let's change it up. Let's stand over here now. Okay? If I was to stand over here and I wanted to find y, how do you want to do it? What do you think?
Tangent.
Okay, I could use tangent, couldn't I? Because if I'm standing here, I'm trying to find y and I know x. Okay, so I could say that the tangent of what? What goes in here now?
The opposite, y.
The tangent of
37.
37 is equal to what?
Y
Over
over 14.38.
14.38. Good. And what's the tangent of 37 in your calculator?
0.753.
0.753 is equal to y over 14.38. So if I make this a proportion, everybody see why I make this a proportion? Because I can just cross multiply. 1 times y is y. 0.753 times 14.38 is what?
10.836.
10.84, rounded off, right? So now I know y. Y is 10.84. So if you wanted to check your work, because it's always good to check our work, if you took 14.38 times 14.38, added it to 10.84 times 10.84, a squared plus b squared, you'll get 18 squared, or something real close. You won't get it to be exactly equal because these are rounded off, aren't they? Okay, but you will get it to be very close. Okay, does that example make sense to everybody?
Yes.
Okay, good. Now, I didn't have to solve for y that way. I could have decided, I could have decided to stand here. Okay, I could have decided to stand there, and now if I wanted to find y and use the 18. Sometimes it's an advantage to use the 18 to find the other leg and not this one, because this one has a little bit of error in it, doesn't it? This number was the given number. So let's find y again by standing here and using the 18. So now I'm standing where? What goes in here for my answer? I'm standing at the 53, okay? What am I interested in? Sine, cosine, or tangent? I'm standing here, what's y? Opposite, adjacent, or hypotenuse?
Jason.
Jason.
This is always the hypotenuse. The hypotenuse never changes. What compares adjacent to hypotenuse?
Cosine.
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 Cosine of 53 is, well, is adjacent over hypotenuse. What side's adjacent to me?
Y. 14.3 or y.
Because I'm standing here,
Yeah,
and
y.
what's my hypotenuse?
18.
18, okay? So if I put this over 1, I can see that y is going to be nothing more than 18 times the cosine of 53. So we can do all that in one step in your calculator. So now go ahead in your calculator, do 18 cosine of 53, enter. What do you get? $18 times cosine of 53.
50.4.
What do you get?
I got,
10.3.
yeah, what he said.
No.
What?
18, well, go ahead and do cosine of 53, enter, and then multiply it by 18.
10.83.
Yeah, that's right.
10.83. Notice, there is a little bit of difference between these two, isn't there? Okay, that's because of round-off error. I would say this one is the more accurate because it used the number that was given to you and not the number that was rounded off, okay? But you won't be counted off for that, okay? But what I really wanted to show you is you can solve the problem either way. You can stand wherever you want as long as it's not where.
90.
You can't stand here. You get to pick where you want to stand, and where you want to stand determines what ratio you need to use to solve the problem. The ratios that you use have to involve what you're looking for and what you know, okay? What you're looking for and what you know. And then you can go ahead and set the problem up and solve it. So the nice thing is you do it the same way every time. The only thing that changes is where you're standing, what function you're using, sine, cosine, or tangent, and set your ratio up. But once you understand this technique, you do it the exact same way every time, okay? But remember, it only works for what type triangles? Right triangles, right? So if I gave you a problem like this, if I gave you this problem, everybody see this little one? I said the angles are 50, 70, and 60. This is 8, find x. How would you do that? Can you use the Pythagorean theorem? Can you use the Pythagorean theorem here?
Yeah.
Yes, you can.
No, you can't because there's only one.
If there's only one, I need two sides to get the third side. But even if I knew this side, I still, what if I said this was 10? Can I find x now?
Yes.
Yes, because you have two.
No, because remember, what do you need to use the Pythagorean theorem? What type triangle?
Oh, a right
Right.
triangle.
Line, a right
This is the right
triangle.
triangle.
That's not
No.
right.
No, you cannot use the Pythagorean tool on this. You got to make sure you have the right tool for the right type problem. You cannot use the Pythagorean theorem. I cannot use trigonometry, sine, cosine, and tangent, because sine, cosine, and tangent all require what?
A right triangle.
So I do not know how to solve that problem yet. But keep that one in mind. By next week, we'll have a way to solve that. But all we know how to do right now, okay, is to solve problems using Pythagorean theorem, two special cases, and trig. Remember, if these two special cases are confusing to you, you can always solve these using trig, just like we did over there. It will always work. This is like vice grips. It has many functions.
Can we use this as notes? Can we take a
Yes.
picture of this and use this as notes? Okay.
If you want to, you can, I can leave it up there now for a few minutes, but if you want to just pull up the
I got it.
recording and put it in your notes, because remember, every test and quiz is going to be open notes. So yes, I would definitely have this in your notes.
Yeah, I just took a picture of it, so I'll write it down.
Okay, good. Did Stephen, let me go ahead and stop the recording because that's the end of class.